Okay. We're going to work on questions 18, 19, and 20. And notice that we have here negative 3 to the nth power. So this numerator is what we describe as an alternating mechanism. What I described as that. And so what we want to investigate now is the absolute value of this statement. We're going to take the limit of the absolute value. We're really making all the terms positive. So using properties of absolute value now. So that's going to be negative 3 to the n in absolute value divided by n factorial in absolute value. Okay, so that's going to give us the absolute value of negative 3 to the n, which is really 3 to the n, that numerator, over n factorial. And the reason we can remove the absolute value sign for n factorial is because n is a natural number, right? N, which means our n is positive. Alrighty. So we're going to now look at the limit here of the absolute value, which will be the limit of 3 to the n over n factorial as n goes to infinity now. Okay. Now, let's really take a closer look here to the terms of what this is by definition. So we're going to say this here is defined to be, if we look at these terms, algebraically speaking, 3 to the n is 3 times 3 times 3. We have n of these. N factorial is n minus 1, n minus 2, down to 2 times 1 here. Okay. So I'm going to separate here. I want you guys to focus on really what? You got this 3 to the n. And let's look at some details here. I'm going to look at the details this way. Let me change the terms. And put it this way. 1 times 2 times 3 all the way up to n minus 1 times n. And every one of these numerators here is really 3. So I'm just writing my factorial backwards. Okay? And then I want you to see that this is going to be smaller than 3 times 1, 3 times 2, times 3 times n, and starting at 2 now. Okay, so you might say we have what over here? those terms, and then you got this last term here, 3 to the n. So this portion is now going to become 27 now over 2 to the n. Okay. And so this sequence here is smaller in absolute value than 27 over 2 to the n. So we know that this portion will go to 0 as n goes to infinity. So we're looking at this going to 0 as n goes to infinity. And so because that goes to 0, this is a smaller, this is the bigger sequence goes to 0 as n goes to infinity. So what that means is that smaller goes to 0 as well. So the absolute value of an goes to 0 as n goes to infinity, and then that means now an goes to 0 as n goes to infinity because of the theorem that we wrote down earlier, which is that if the series in absolute value goes to 0 as n goes to infinity, then an goes to 0 as n goes to infinity. So this converges here. And this is a different kind of logic for you than Calculus 1 or Calculus 2. So it's in Calculus 2 here. Okay. Now, similarly here, with n factorial and 2 to the n now, let's write this one down. What this one actually means as well. So I'm going to write it the same way. N factorial, by definition, I write it, we'll write it backwards so you guys can see the logic. So this here is 1 times 2 times 3, all the way up to n minus 1 times n. That's my numerator. And then I have, under every one of those terms, 2. I have n of these terms. Okay. So we're going to focus on now here these terms and know that this is going to be greater than or equal than 1/2 times n over 2, which makes this portion here n over 4. So let's take a look. An is greater than or equal to n over 4 now. And this is for n greater than 1. Okay, so we're going to say this here. As n goes to infinity, the smaller sequence goes to infinity. So we're looking at the smaller sequence here going to infinity. So what that implies now is that the bigger sequence also goes to infinity as n gets big. So we have the sequence diverging here. So this sequence will diverge. So the smaller sequence gets big without bound. That implies that the larger sequence gets big. And that larger sequence is A n. Got divergence. And then finally, n squared minus 1 for number 20. We look at the limit now as n goes to infinity. N squared minus n is an indeterminate difference. So we're going to get to use here algebra, calculus 1. So factor out your n, and we get n minus 1 here. So we'll have the limit as n goes to infinity, n times n minus 1, which we now get by the product rule of limits, infinity times infinity, which gives you infinity. So here's what this means, I guess. We can say this. An goes to infinity as n gets big, which again now means your sequence simply diverges here. Okay. All right, I will send this to you guys. I hope you guys enjoyed this demonstration. I finished the worksheet for you.